Now let's consider another kind of conditional statement. This one's called a two-way branch, and it's used if you want to decide to choose option A or to choose option B. So you're always making a choice to either do one thing or the other thing. In this case, it's not possible to skip both of the conditions. We'll see later that there is a way to do that, but that's not what the two-way branch is doing. It's always choosing option A or option B. The syntax for a two-way branch looks like this. It's called an if-else statement. It starts with the reserved word if, then we include the Boolean expression as a condition inside parentheses, and then include the colon. After the colon, include all the statements, which can be one or many, that belong with the if part of the condition. We'll call that the option A group. And then after that, include an else statement. Notice that the else statement's not indented, has to line up just under the I in the if, and it ends also with a colon. And then all the statements that belong with option B belong under the else statement. When the computer encounters this kind of logic in its program, it first evaluates the condition. And remember, that condition has to be a Boolean expression. It always has a true answer or a false answer. If the answer is true, it executes the statements that are part of body one. That's the option A group of statements. On the other hand, if the condition evaluates to false, then everything under the else block executes. That's the option B statements. Those would execute. Regardless of which body is chosen, the computer continues on with the rest of the program when it reaches the lines after the body portion that executes. Notice that in this kind of statement, you can't have both option A and option B execute. Only the one that is associated with the result of the condition will execute. Let's look at an example with our temperature program. Suppose that we look at a situation where we want to either print a message saying it's cold outside, bundle up, or we want to print a message that says no need for winter gear today. And regardless of what happens with the temperature, we always want to print out a final message saying continuing on with the rest of the algorithm. Look how our conditional statement accomplishes just that. We're still prompting the user to enter their input value. Then we have our conditional statement that matches up with the logic that we want to have associated with our first group, the option A group. Option A represents when it's cold outside. So we want to print this message, it's super cold outside, bundle up, when this condition gives us a true answer. However, now if the answer is false, we want it to print an alternate message. We want it to print no need for winter gear today. So we associate that second group, the option B group of statements, under the else. And then everything that's not indented under the if or the else is something that's going to execute all the time, regardless of the temperature value. Let's look at a few examples and see what happens. What happens when the user enters a 20? So if the user types in a 20 when prompted for input, that'll be stored inside our variable called temperature. When the computer encounters the if condition, it evaluates the expression. Is the value of temperature less than 32? And in this case, that's going to return a true value. 20 is less than 32. So it's going to execute the group of statements in option A and print, it's super cold outside. Bundle up. It's not going to do any of the else statements. That's because it's already executed group A statement. So it skips everything down here in the else. It picks up with the unindented statements that follow. So in this case, it's going to print continuing with the rest of the algorithm. Awesome. Let's see what happens if the user enters a 90. So if we prompt the user for input and they enter the value 90, that will be stored inside our variable called temperature. When we reach the if condition, computer is going to evaluate the expression, is 90 less than 32? In this case, that gives a false answer. So all of the statements associated with the if are going to be skipped, and the computer will pick up the execution with the else statement. Else means always do this other option. So it's going to print out no need for winter gear today. And then the computer is going to continue with the rest of the algorithm, the part that's not indented. So it will print out continuing the rest of the algorithm. Finally, let's look at what happens if the user enters 32. So if the user is prompted for input and they enter 32, that will be assigned to the variable called temperature. Then we're going to check to see, is 32 less than 32? And that's false. So the computer is going to skip everything with the if block. It'll pick up the execution with the else and print out, there's no need for winter gear today, continuing on with the rest of the algorithm. So the output's going to be identical to the output that we got with the 90 input.